Good morning.
Hello.
Hello, sir. Good morning.
Good morning.
I can see that there are some students still coming to our lecture. However, the time is going on, and I should start a minute ago, so I will not wait anymore. I will start our lecture. And as usual, I will switch off my camera in a minute, and I will present you on a screen the slides and other, I hope, interesting things that I will discuss and I will explain during this lecture. So I am switching off my camera, and now let's go and let's present the topic for today's lecture. So starting from the last lecture, I gave you the introduction to the information systems modeling, and one of the last slides that was presented on the screen was that one. I told you that when the project starts and when the development is going to have a place, the people must decide which format, which language they will use, what kind of the standards they will use in order to deliver proper documentation. And then once the decision was taken, every member of a project team must follow the rules and use a particular way of modeling, should use particular tools and so on. In that approach, when you start your implementation from the model, sometimes that approach is called model-driven development. And in that model-driven development, you can use several standards or several languages by which you describe the particular part of your system, the particular interfaces, data structure, and so on. In that slide, you can see that these languages have a different expressiveness, so different part of the word can be modeled with use of them. So there are entity diagrams, there are models of the XML schemas, and there are several diagrams which are offered in UML, and so on, right? So today I would like to focus on some parts of this modeling languages. Namely, I would like to switch to the SysML, which is not mentioned here, but was mentioned last time. And I will also talk a bit about UML models. So let's switch to the current presentation, and let's start with some remarks about the standardization. The standardization in the domain of the modeling has a long history, and that standardization is run by various organizations. Standardization processes are run by various organizations. So maybe one of the most known organization is ISO, International Standardization for which already publish documents. Here is the list of these documents in which particular notions, particular languages have been described. So there is a BPMN standard which is used in order to describe processes and model processes. There is a common object request broker architecture, the standard that was quite popular a few years ago. This standard is used to describe interfaces of the distributed systems. And in fact, was popular because it offered something that was not possible before. It offered a universal language by which requests, responses, data structure, and so on, and many interfaces could be described and exchanged between various parties, between various implementators. And this standard was how to say, was not platform dependent. So the description written in that standards could be then implemented in C, in Java, in Smalltalk, in any other language that support mapping from that description into the data structure of particular language. So there are some other standards. There is a KDM and the model which is used to exchange the meta model of various knowledge models. There is a meta object facility. There is an object constraint language, and so on. And what is maybe important and interesting for you is that OCL is the so-called, we can call it as an extension of UML, because what you have in UML, these are diagrams which can be enriched with some information in which you will include some limitations, some restrictions. So that language by which you express these restrictions is just OCL, object constraint language. And this language is a language by which you put annotations inside your UML diagrams. And thanks to that annotations, you can limit the use cases, you can limit the scope or the domain and ranges of your variables, and so on. There is an XML metadata interchange language, XMI. This is interesting that UML in general is a graphical model, graphical language, right? With use of that language, you can draw diagrams and you can link the particular boxes in these diagrams. But if you want to exchange this model between different systems, you must serialize this model somehow. And XML metadata interchange is just a standard which was designed just in order to serialize the UML models into the description that could be exchanged between systems and could be used to upload this description to the other environments. And it is also interesting that XMI became an extension of the file names which was used or is used in to annotate or to declare the files, which includes the description of UML models. However, various companies which deliver designer tools implemented that standards in a bit different way. So if you use IBM tools which export XMI files, these files not necessarily will be loaded by the enterprise architect or any other tool, because as I said, some companies implemented that standards in their own ways, and portability is not preserved. So this is a pity. Even the standard exists, sometimes it's quite difficult to exchange models between various systems. Oh, so here is also SysUML, the standard that was developed by OMG and then was published and adopted by ISO as an ISO standard number 19514. And this OMG is an organization. If you go to the OMG organization, it is not a audio what I am looking for, but object management group, and this object management group just declared several specifications which are, let's see. So there are several specifications which are used by in the various parts of the in various domains. There are standards used for business modeling, enterprise modeling. You see, there are several such standards already delivered. For example, if we go to the business modeling, so you can see that here is a business motivation model, business process definition, meta model, several documentation in which you can find the description how to play, how to use these standards, what you can do, what is its expressiveness, and so on. Right. So let's go, for example, for BPMN, and here you should have a chance to go to the standardization, and I think that one is the current one. And here is the specification, and inside that specification you can read, right, what is the BPMN and how to use that standard and so on. This is like a book. However, this book is very specific, right? Sometimes it's quite difficult to read it because it is very formal. It just it has some examples, but it's very formal. It has some definition at the beginning, conformance, normative references. Do you remember the first lecture I told you that when the documentation is prepared, official documentation, it should follow some schema. And this schema requires to put at the beginning some introductory material, some definition, and then there is an overview and the description. This, in a case of the standards, this description is very formal. Sometimes you can see the diagrams that are readable and very, how to say, these are examples. However, when you go into details, you will see then that there is a list of the formal description, the formal definitions, and sometimes it's quite difficult to read. Therefore, in the libraries, you can find the books which gives you some introductions or just explanation how to interpret these standards. So here I'll also like that. Examples, non-normative documents. In these examples, you will find some proposals or some overworked use cases in which you can, how to say, familiarize yourself with the standard. However, this is not a normative. It means that what is written here is just to inform or to present some ideas. This is not an official release. This is not the document that is interpreted as a standard. However, it is, and it is quite informative, and you can learn something from that document. All right. So going further, I told you that today we are going to switch or to talk about SysML. SysML is a standard which share some common diagrams with UML. So formally, UML version 2.5 it was adopted in 2017, and OMG SysML was released on May the same year, and in fact both standards have been adopted as an ISO standards. And this is also interesting. If you wish to download ISO standard, for example, I put it in my web browser to search for, and you can see when you go to the ISO web page, you can buy the standard for quite a large amount of money, right? Well, these are Swiss francs, and it is costly. However, all these standards which are adopted have their origins in the web pages of the organization that designed it. So if you wish to read that standards, go for free, go to OMG or any other organization that published the standards, and probably you will find the version that is official, but you can download it for free. So this is also interesting that ISO, once adopted the standards, keeps the records and offers the standards charging for them. However, the origins, the source documentation can be found on the organization's web pages, and it is accessible for free. And right, what is this SysML? SysML reuses some parts of UML. Some parts of the diagrams are exactly the same, but there are some others which are specific to the SysML. So what are the version of SysML? Currently, we are working, or current version is 1.5, and there is a history of changes. You can see that the deployment started with version 1.0 and finish with the version 1.5. And this SysML diagrams can be divided into three sections: behavior diagrams, structure diagrams, and requirement diagrams. This behavior diagram are diagrams which are used to declare some dynamic parts of your system. So activity diagram, sequence diagram, state machine diagram, and use case diagram. So in general, those boxes which are drawn with a solid line are those which comes from UML. So these are almost the same. The diagrams drawn in thick solid line are diagrams which have been modified a bit when compared to the UML diagrams. And these diagrams which are drawn, or the boxes which are drawn with the dashed line, these are diagrams, depict the diagrams which are specific to SysML. They are not existing in UML. So for me, and generally for us, those requirements diagrams are especially important. So in general, these diagrams, here is a picture in which you can see the graphs showing parts of these diagrams are, as I said, can be divided into structure and behavior categories, and in every categories, what you can draw takes a form of blocks or with arrows, with lines. The interpretation of these blocks and arrows is described inside the specification. So in SysML requirements diagram, you can specify the requirements, and the requirement is something that collects the information about capability conditions that must be satisfied in order to build a system. So requirement collects these descriptions. The requirement can appear in other diagrams, not only in a SysML diagram, but also in others, and can be linked, just making a quite interesting model. So I will come back to this in a minute. Just now, let's see how the SysML requirements look like. So in general, the requirements that can be drawn on a screen, and then that can be converted into the tables, are like that: containment, trace, copy, derive, verify, refine, and satisfy. So these are stereotypes which are used to annotate the block. If the block is annotated as a requirement, it means you are declaring the requirement. If you want to specify the relationships, you can specify that one requirement is a containment of the other, that one requirement is a tray of the other requirement. So these links that are used to connect one requirement with the other are relationships, and they can be, as I said, declared as a containment, trace, copy, derive, verify, refine, and satisfy. And in general, this on the left is what is written in the specification. However, some of the software providers offers the tools in which they change a bit the naming. Okay, so for example, in Spark system tools, which is called Enterprise Architect, SysML requirements have some extension. There is an extended requirement, functional requirement, interface requirement, performance requirement, physical and design requirement. So they deliver more specific requirements, which are depicted in the screens and by a bit different annotations, a bit different or stereotype. So how it looks like, what are the tools which you can use in order to draw such diagrams and to play with these diagrams? There are already several existing on the market. There is, for example, the Integrity Modeler. In the Integrity Modeler, you can build requirements and you can play with them. You can draw them in such diagrams. You can define the use cases and the user that can access these use cases. And in SysML, you can combine, you can link these two diagrams, use case with SysML diagram, with requirements. What is this use case about. So the accelerate car is a use case, and this use case, in order to be fulfilled, must have some condition to be fulfilled. And this condition you can describe in the text. A master seed then shall have a reservoir, and so on. If you have the requirement that is described on a very general level, you can create a structure in which you depict more specific requirements that derive from that requirement. Therefore, there is a derive requirement association. You can put a new requirement which derives from the first one. A new requirement that derives from the first one. So there is like a derivation tree in which you can specify more specific requirements based on the basic requirement. So this is what you can do in SysML. If you want to deliver some comments, you can deliver these comments as a comments block, so satisfied by something. This comment block, in fact, is a way which you how to say, satisfied by is also one of the associations, and this association can be modeled with use of the this kind of the can be depicted with use of this kind of that you can put inside the description of this satisfied by the name of the part of your component, which is a part of your system, which is a part of your implementation, and you can say that the module brake system M is just something that satisfies this requirement. If you collect several requirements in your diagram, and your system and your requirements grows and grows into a very large model, at a certain moment you can be lost which of the requirements have been already implemented in your system, which do not have any matching part. So with use of SysML, you can handle this case. You can put inside your diagram the relationships that one requirement is already implemented, is already satisfied by some part of your system. So here you have a link between implementation and the requirements written in a text just by this association. Satisfied by is used to declare that some of the requirements has been already met and are satisfied by particular part of your system. So in general, going back to the previous slide, building the requirements with use of SysML is a nice way of organizing these requirements in structures, right? It gives you a chance to handle all these dependencies in an organized way. So one of the relationships that can be modeled is called containment. Can you see, right? And here is the example of that containment. One requirement can be combined of two others requirements, okay? The composition is a bit different than derivation, right? Containment and derive are different associations. So composite, or let's say containment, is something that can be used to declare that one part is composed of several parts. So to have the composite ready, you have to have ready both composites, both parts of which this composite is built from. So it means that this is like a how to say, this is like in a set theory. So composite is a sum of sets which are below. Derivation is something else. If you derive requirement, this is like a derivation of classes. You specify a more specific class with maybe more features than the previous one. Composite is a composition. All right, so you can declare derivation using association deriv requirement like that. So source requirement, derived requirement, and there is an arrow going from derived requirement to the source requirement, which is annotated with deriv requirement stereotype. And but this is not the only case. You can also depict the dependencies between particular requirements using another notion. So, for example, here I have requirement, which has a requirement name, and it has also properties: derived from, masked, refined byte, satisfied byte, traced to. So, as you may see, instead of putting the blocks and link them with a deriv requirement, I have one requirement that has all these associations already embedded into the form of one block. So this is also allowable with use of that, how to say, you can create the blocks without links. However, these links are embedded inside that block in the form of the fields of that block. And of course, there is an ID and text which are used to uniquely identify the particular requirements, and the text is the textual description in which you can read what is the main topic covered by that requirement. So, right, there are different ways of expressing the model. You can build the graph. You can also build a graph like that, but you can also declare the blocks which instead of having links, they are attributes which are already embedded inside that block. So here is another way of expressing the relationship between various requirements. So there is a, for example, relationship copy, that one requirement is a copy of the other requirement. So this is also quite interesting because with use of the copy, you can declare that you can declare another requirements. You can rename this requirement. You can put different name, and you can specify that this requirement is a copy of the other one. So in fact, they are exactly, the content is exactly the same, but they are named in a bit different way. Why I said so many words about this copy? Because during the first lecture, I told you that when you are declaring the systems, you can look at this systems from various perspectives. So if you are working from the business perspective, your view is a bit different than if you are working in the perspective of into engineering perspective. Therefore, sometimes you are using different wording, different terms in order to communicate with within the scope of the particular view. And if you in one view refer to exactly the same requirement, however, the language or the keywords you are using are a bit different. So you can use copy just to make a copy of these requirements, name it in a bit different way, but inside the description of this requirement will be the same. So this is the uses of the copy relation. And in general, building the requirements with use of SysML allows you to organize them into the packages. So you can say that some of the requirements are business requirements. Some of the requirements are concrete requirements. Some of them are related to domain of interest. Some of them are related to performance. And in that way, you can, how to say, build a structure and build the categories in which you can collect particular requirements. And having copy relationships, you can just link, right, between these two, between different packages, just to say that these requirements are exactly the same. So this is something similar to the organizing. It's not similar, but the use case which you can refer to in order to explain how the copy works is like in Google Mail. Have you ever used the labels in Gmail mailbox? Right? Have you used labels? Do you know what I am talking about? Gmail labels. So if you have an email box, so you can declare the labels, and then your messages will be annotated with these labels. But you can also have to split your labels into different folders, split the messages into different folders according to the labels. In fact, you have no folders, but everything is collected in one bucket. But these labels allows you to filter this maze into filter and organize them like in virtual different folders. So copy relationship is other mechanism that is used here. With use of the copy, you can say that two entities are, how to say, contain the same content, but they are named in a different way. So this is how the copy relationship work. So what we have also, as you may see, that you can specify a relationship between the requirements using the arrows. You can also say that one requirement is derived from the other requirements, putting that dependency inside the comment block. So instead of associations, you have that association written inside the comment block, and so on, right? So this is another way of expressing the dependencies between various parts of your requirement diagram. As I said, this requirements diagrams are very helpful in describing and organizing the description of your systems. Yeah, I can show you one of the diagrams. I'm sorry, it's written in Polish, but I will explain you what is the content of it, and I will try to translate shortly how it is organized. So my student, when he was writing his own thesis, collect its requirements in the requirement diagram. He said, for example, that his system should discover some states based on the history written in some logs. So he said that this is what the system should do. The system must recover its states based on the description, and there is these requirements. Having the information about the previous states and the configuration, the system has to detect its own position and so on. So here is the requirement. The requirement has its own ID, has also some other attributes, so ID and textual description are obligatory, but he also put some kind of the additional attributes. He proposes status. In the status, he collects the information about whether the requirements was already fulfilled, or whether this is a proposal or whatever. He also put some risk, because risk is one of the factors which, when handling the requirements, is very important. If you have some very high risky requirements, maybe you should start your implementation just from them. So you can put this additional information inside your description. For example, here is an attribute verify method. So he specified that that particular requirement should be verified by running some kind of the tests. And he also put here the kind attribute, in which he specified that this particular requirement is belongs to the functional requirements category. So as you may see, with use of this SysML diagrams, you can put more attributes, more data inside particular requirement. Instead of putting requirements into the packages, that student just put inside his description additional attribute, which is called kind, and using that kind attribute, he could how to say, select or filter out which of these requirements are functional, which are not functional. What you can see also on the diagram is that he put here that that particular requirement will be verified by test case. And this test case has been also described with the text. Inside that text, it is written that what is the main idea of the test. That test should check the differences, or should recognize the states of various fields in a game, because this requires in general related to the application the student was implementing, and this application was just for playing chess games with use of the computer and camera. So as you may see, here is the requirements. There are two obligatory attributes like ID and text. There are some additional optional attributes used and declared, and which are also put it here. And I have a verify associations that says that these requirements must be verified by this kind of the test. And as you may see, the student also drawn this diagram in a very nice way, namely, he put requirements in a column, the tests in a column, and use cases which are related to that diagram in a separate column. So in that way, I have an overview of how the system. Let me check whether I have use cases. Here I have use cases as well. Oh no. Somewhere here, here are the use cases which are related to the system, and these use cases are described in more detail using this SysML and SysML diagrams. All right, so this is what can be done, and what is also important is that when your diagram grows, or when the number of requirements becomes very large, so it's quite difficult to handle all these requirements on a screen. It is difficult to handle them on the diagram. So SysML allows you to put all this specification inside the table. So the standard gives you the description of graphical language, but in that standard SysML, it is also written that your specification can be represented inside the tables. And in fact, the tables are really most usable when the number of requirements gets large, and when you need to handle a lot of the descriptions. So the tables are the best. So when you deliver me the software requirement specification, you can draw your or you can specify your requirements using the diagrams. But as I said, it is quite useful and handy to put the diagrams inside the tables. So I accept both kind of the description. So as I said, UML, SysML diagrams are the diagrams that are very specific to SysML. However, SysML share some common with the UML, and the UML in general is a set of set of various specification of various data structures of various diagrams, and we have in UML structure diagrams and behavior diagrams, as in SysML, as I depicted on the previous slide, one of the previous slides. And here are 13 diagrams split into 3 categories, and the structure are used mainly to declare statical part of the systems, and behavior diagrams are these diagrams that are used to express the dynamics, the behaviors, the changes that might go once the time passes. So these are just the names of these diagrams, and one of the most common used diagram is a class diagram. This is what students learn during the courses, and this is what programmers familiarize themselves during the implementation. And let me show at the moment how to play with this kind of the diagrams once you start the implementation. So here I have on the screen the Rational Software Architect. So this is a software that is delivered by the IBM, and if you wish to play with that software, you can enroll or subscribe to IBM Academic Initiative. So there is an academic initiative run by IBM, and you can subscribe to this academic initiative. And once you subscribe, you will get an access to the commercial software, which you will be allowed to download and use for free until you are the students of the university. So IBM initiative has, as I said, several tools. One of these tools which can be downloaded is IBM Rational Software Architect. So I have it here, and this right. Okay. So this is a version 9.7, which runs the license, educational license. And inside that tool, I have several features. Generally, this tool is based on Eclipse and allows you to do a forward and inverse engineering. So how it works? Let's start a new project and let it be Java project. I will call this project as a TTT. It doesn't matter the name of that project. And inside that project, you will see there is a structure which is familiar to you. There is a SRC folder, and at that folder there will be stored a new classes. So let me declare a new class which will be in package X1, and I will put here the class should have a main method after finish. So I have the class with main method already declared. So let's do another class, and I will say that I am interested in having class B, which will be in the same package, but this class let's derive the features from the A class, and I have a class B that extends class A. So I have two classes. And in general, in object-oriented programming, this is what the programmers do. They declare classes, and the classes might have properties. Private string name. Okay, this is the field, but maybe this field is better to put. No, I will put not private but the public field here. Okay, here is the public. Class B will get that field as well because it is a public, and by the derivation it will be accessible in the instances of class C. So this is what the programmers do. They just code classes with the methods and the properties. However, this coding can be organized in a better way. I mean, you can declare, okay, maybe I will put something more just to make a better example. I will put here the interface. It will be called I, and okay, finish, and I will put the declaration of the method in that interface. So I have two classes, and let's say that class B will implement interface I, and because this class must implement that interface, it must deliver the implementation of the method of the interface. Okay, three classes, one interface. And normally when you program, you are using that kind of the source code writing. However, you can also do something more. Here I will I will ask my environment to declare class diagram. Okay. So inside my project, I have the folder for the diagrams. This class diagram is at the moment empty. So I will go to the folder with the sources, and I just moved my classes inside the class diagram. What the tool do for me, it just allows me to, it just produce me the, as you may see, the diagram, doesn't matter, the UML kind of the diagram. This is not UML exactly. This is the diagram, which is very, how to say, similar to UML, but this is a diagram which is Java, which is a Java profile diagram. It is used to express the classes and the properties which are written in Java language. So as you may see, here is the stereotype Java class. Java class, it means that it is encoded with use of the Java language. And what I have here, I have the navigation. I can switch from source code to the diagrams and from the diagrams to the source code. For example, I can assign, not that in that way, I can put here a new field. I can declare that there will be a surname as a field, and the type of this field will be string. And I will declare this field as a public, and it will be declared in a class B. I can also specify some annotations. I am not doing anything more. I will skip it. And now I have on the diagram additional field, which is called surname. So as you may see, when I go to the class, this surname appeared here. So here is the direct communication or direct path from the source code to the diagrams and from the diagrams to the source code. So sometimes this kind of the how to say of the paths is called forward engineering and inverse engineering, right? Having the classes or having compiled classes, you are retrieving the diagrams, and having the diagrams, you can receive the source code of your classes. So you can do both ways with use of the tool. So it is quite nice having that possibility. You can just draw diagrams, or you can program just by drawing. If you wish, for example, to declare additional class, which is called, for example, C, you can put that class here, and you can say that that class will derive from the other class. Just, you may see, you are programming by clicking, by drawing, by putting some parts on your diagram, and what appears in the source code, you will just get all the declaration ready. So the pity is that this tool, Rational Software Architect, supports only Java 1.8. It does not support additional features that were inserted inside the language, like var keyword, like the lambda expressions, like some other parts which are, how to say, that exist in current Java language, but this tool is not able to handle this new construction in the language. I don't know where the IBM is going to update this tool to the new constructs in the language. However, if you wish to stay with the standard Java without any new improvements, so you can use that tool to design your classes and your diagrams pretty easy. It is not the only tool which can be used to create the UML diagrams. Spark's enterprise architect, Spark system delivers enterprise architect, the tool that has many features, but it is commercially based, so you must pay a fee, you must buy the license in order to use it. We have no any educational license available, so I cannot offer you any access to the tool. However, if you are thinking about a quite nice tool to play with models, this is something which I really like, and it is a very efficient, very modern and well-working platform. So you can design the mockups, you can design the sketches, you can design this SysML diagrams, BPMN models. So many kind of the standards are already implemented inside the tool, and it's very good tool. Another tool which is available for students, you can apply for the educational license, I think, is a Visual Paradigm. Visual Paradigm also has some features. You can model various parts of the diagrams. You can draw class diagrams, you can draw state diagrams, you can draw BPM diagrams, you can even handle user stories, and you can support your agile environment with the tool. So this is what you can do, right? However, as I said, there is a free version and commercial version of the tool, and this tool is built on Java, so it's a bit more heavy than Enterprise Architect. All right, so this is what I wanted to show you, that with use of various tools, you can model your system using different options which are available. If I want, for example, in this Enterprise Architect play with pure UML, so I can declare a new project which will be where it is general. Let's see. This is for data in general project. And there is a new project, and inside that new project you can run there is a model, and I can run where it is UML model, standard template, next, and next. I can select various parts which I can use afterwards in the modeling. I'm just pressing next, just to go in a fast way to the end. And as you can see, I can create various diagrams inside my model. I can create, for example, a topic diagram, and I can, in general, I can declare many things here. So let's say I will create a class diagram. Okay. I can select a support for various parts of various libraries here, but I am not doing anything. If I would select Java modeling, so then I will have a chance to work with Java code and Java diagram, but I am not selecting anything, just to show you that this class diagram I am using here is a bit different than the class diagram which was declared when I was playing with Java code. Now that class is a bit different. I can, where it is UML, I can add, okay, somewhere here there should be possibility to add the class, not that way. Okay, I haven't used it for a long time, and so I cannot see. All right. Okay, maybe here it is, add class diagram. Okay, and here is a class diagram, and in that class diagram I can add class, and I can add second class. I can link these two classes with use of some associations. So what I want to say is that when you are working with a pure UML, so the number of features is a bit different than when you are working with a Java class diagrams, right? UML is a language that can be used to declare anything that how to say, that follows object-oriented paradigm of the modeling. And you can specify your own profile, you can specify your own stereotypes, and this is much more advanced language that is used when you are designing Java classes. Okay, Java classes are the set of the features, and then the number of the associations you can use is limited. But if you are working with a blank packages, with a standard UML classes, you are doing something more. There is a possibility of converting that kind of the description into Java code, but this is done in the tool through transformation. Here you can define the configuration that in which you specify that you are going to transform your UML model into Java code. So this is something which is on, let's say, on different level of the modeling. So summarizing, with use of the various tools, you can model, how to say, different parts of your system. And even if you stick only to the class diagrams, you can see that even in that case, there are many options. You can have the tools which are working just on a pure UML model, but you can have also, you might have also the tools that are profiled to support modeling in particular language. So as you may see, these diagrams looks differently. Here I have the stereotypes Java classes, I have some icons, right? And if I working in a pure diagrams, so the depiction is a bit different and the number of features is also a bit different. All right, so going back to my presentation, inside that presentation, there are few words about class diagrams. So class diagrams depicts the static view of the model or part of the model. In general, they describe the content of your classes and dependencies between these classes. Each class is represented by a rectangle that has three compartments. It has a name, so this is the name with the icon. It has the attributes, which is the first part of that box, and it has also operations which are inserted in this the next part of that box. Operations or methods are usually described with the return value, and if the methods take some arguments, these arguments might be written in a braces, but usually the attributes are on this diagram written just passing the data types without naming these variables. However, if you are interested in doing some more depictions, or if you want to describe them in more details, you can change that view into more details, in which you can specify also not only the data types, but also a name of the attribute. And as you may see on the diagrams, each part which is depicted with a green icon, it is a publicly accessible part, which is written in with a red square. It is a private part of that class. However, without using any icons, you can use the notion in which a plus means a public part, minus means the private part, and I think that hash, it is written here, no. Hash is also used to declare protected part of the class. So as I say, the depiction of the UML diagrams may vary depending on which kind of the what kind of the style is used to display these diagrams. And what is also important, what I wrote here, with use of the diagrams, you can declare classes, and these classes might be, implementation of some of design patterns. Okay, so I started from that slide, the introduction to the design patterns. You can see that here I have the student DAO. So it should suggest you that something is going on here. And in fact, it is. What I wrote here, or what I declared here, is a pattern which is called data access object pattern. In that pattern, the idea hidden behind that pattern is that if you wish to play with some data stored inside the database, you can declare at first interface by which you will extract the data. So in DAO pattern, you start your implementation with the declaration of methods by which you can access data. Add student is a method which having a student instance will insert that instance into the database. Get all student is a method that should extract your students from the database. Get student which is identified by particular ID is a method which will be used to extract the students from the database, and so on. So these are access methods which are declared in the interface, and that interface then should be implemented by some class. By a class, here is a student DAO imp. So as you may see, here I also used the some kind of the method of naming strategy. If I have the interface and class that implements that interface, I assign at the end of that class impl part, which just depicts me that this is the implementation of the interface. So naming conventions are very important, especially when you are starting your implementation in a team. If you and especially in Java, because many of the mechanisms which are hidden behind various frameworks are based on naming conventions. So here I use that convention that if I have the interface, the class that implements that interface has its name imp at the end, and the name of that class matches the name of the interface. And here I have the student, which is the class that preserves the data of particular students, and this type is used as the data type of the attributes which are given to the add student method and which are returned from get student method as well. And DAO pattern demo, it is a main class with an entry point which will run the whole program. So this is what you can see. The number of patterns which are available or which are already described is quite large. If you go to the internet and look for, you find out the Very nice book, Gang of Four Design Patterns. Gang of Four, these are four authors which wrote the book about various patterns which are how to say used in the industry, used when programming in object-oriented way. And as you may see, this is there are singleton, factory, abstract factory, builder, prototype, adapter, and so on and so on. That pattern which I was talking about, DAO pattern, is it here? No, it's not the one of the patterns which are named here. However, it is very similar to the facade design pattern. The facade design pattern just relies on declaring some interfaces which collects the method by which you can access various functions in your system. Not going into details, right? I will let you read that book and find out the description of these patterns in the free time. I will show you that some of these design patterns, right? I already downloaded some source codes of these patterns, and I put them inside my Java project. And here is the facade pattern, and there is a demo which ran that pattern. So you can find out the source code of these patterns by yourself. And that with the student patterns, let me check, I did it somewhere. Right. So this is the example of the project in which I used this DAO pattern. What you can see is that I have the student class, which has his attributes and has an access methods gets and sets. Here is the interface, which is, as I said, the collection of the methods which could be used to access the data. I don't know what kind of the storage is used to store the data. I only knew that if there will be a class that will implement that methods, the set of this method is as on the definition of that interface. And I have the implementation. So as you may see, here I am using JDBC, the technology which is part of the Java JDK. In that technology, in the static initialization of your class, you can declare that the class must load SQL driver, and after loading that SQL driver, I can connect to database. So I have the connect method implemented. This connect method just asks driver manager to open the connection to testDB, the file which will be stored on a web on my disk, because I am using SQLite driver, which in fact is a driver allowing me to operate on a file with use of SQL language. So here is a connect method, here is a disconnect that close the connection, and here are the implementation of my methods. Delete student, if I have the students, I am just preparing the delete request using SQL language. I am creating the prepared statement with use of that declaration, and then I execute update. So after that, my database will be uploaded. The students will be deleted from the database. I have get all students, right? So the implementation which is done here looks like that. First, I declare the SQL request, then I am connecting to the database, then I create the statement is executed, and so on. So as you may see, the implementation of this DAO pattern relies on writing the code which will connect to the database and manipulate the data on the database, but the user who will use that class will only be interested in signature of the methods, will be only interested in having the possibility of running method defined in the interface. So how to use that that pattern? Here I am declaring a new student DAO imp. Then if I want to add the students to my database, I am simply calling the method add student. If I want to retrieve all the students from my database, so I am calling this get all students from my DAO class, and having them, I can print the data which are retrieved, and so on and so on, right? So summarizing that part I showed you. There are several well-known problems in programming in object-oriented manner, and these problems has been already overworked, and the people designed various patterns which helps to play with these problems. And the pattern I showed you was a DAO pattern with the interface and implementation and the use of that interface. And this is quite common use pattern when trying to implement the data storage in the databases. So I will, during the lecture, come back to these design patterns. From time to time, you will see on my slides next example of these patterns with some of the description. I hope that in that way you will enrich your knowledge about the design patterns. I don't want to spend the whole lecture on describing each pattern in particular, because we have several topics to discuss, and design patterns are only just illustration to the problems which will be explained during the lecture. So going back to the UML and going back to the class diagrams, when you design this class diagrams, you can put classes into the packages, and once you do it, once it is done, the conversion of your design into the source code will be also modified, and you will see that the packages declaration in your source code will appear as well. And here are the associations that can be used when you declare the classes. There is a general association, there is an inheritance, realization or implementation of the interface. If there is a dependency, here is a dependency relation. If there is an aggregation, strong and composite so these are these kinds of the arrows you can use. If the association between two classes is represented by the arrow which is not navigable, so here is the cross on line, and so on. What is this especially? If I have the relation between two classes, so let me come back to the diagrams and this class diagram. I can specify, for example, here that I have the attribute which I will call attribute 1, and let this attribute will be multiple attribute, and attribute and type, select type, it will be class 1, class 2, rows. Okay, class 2. Okay. So I declared here the attribute which is declared in pure UML as something that is of the type class 2, but can appear as something which is one or more. Okay, so the multiplication, how to say, the number of instances of the attribute that will be one or more. What it means that attribute can be represented by some kinds of the collection. Do you understand? Maybe I will repeat. When I design the model with pure UML, I can declare attributes using the declaration of how many instances of these attributes of that type should be present in my class. So I am declaring something that is a collection of the objects. And UML, you can declare it as I did. However, when you convert that description of pure UML into the Java language, the conversion must decide whether convert this attribute into the table or convert this attribute into the collection, into different data structure. Do you understand? Is it clear? I don't know whether whether my description is easy to understand. In UML, you can declare attributes which are single or multiple attributes. And if your attributes are multiple, multiplicity is one or more, it means that when you start the implementation of that class, this attribute should be represented by some data structure. And you have the option table, or you have an option list. And it depends on the conversion or transformation between model and source code, how that description will be really converted. So in my example with the class diagram at the beginning, it was TTT, right? This was my diagram. Here I had no problems, right? If I am working with in a Java code, using Java stereotypes, I can declare here public not that, public int tab e, and I can declare public list integer li. Okay, a list should be imported. So I have two attributes, tab I and li. These two attributes are parts of my class. If I switch back to the diagram, so now I can see that I have the attributes. One is a table and the other is a list. So exactly the data types are specified here. But when I was working on a pure UML, you remember what was just a minute ago? So I have an attribute which is declared as an attribute that that multiplicity of it is one or more. So this is a different kind of the modeling, right? I am just out of any knowledge about the data structure the language supports. I'm just declaring attributes with various multiplicities. But when I am working with the Java profile of the UML, during the declaration of this attributes, I can select specific data structure. I can select the table, I can select a list, I can select something else. So this is a quite big difference. And the conversion between UML model and the particular data structures in particular language is not obvious. Sometimes you can get different results if you select to, for example, represent your attributes as a table or as a list. So you will receive quite different source code. So modeling, even if you have standards which are well designed, well described, and which allow you to model the classes, in general, even you have the model well described, you can receive various source codes, various implementation in different languages, even in the same language. In Java language, one model could be converted into different data structures. So this is the warning that UML, in fact, is a very, how to say, very elastic and very abstract language. And if you want to be sure that everyone in your team and everyone in your project properly interpret that models, you must put some restriction on it. How to convert this model into the data structure, or which kind of the profile of that UML must be used throughout your organization. Otherwise, during the implementation, you may face the quite big problems. All right, so what we have else, in UML, you can also specify the relationships between two classes, specifying the attributes by which these two classes are related. And navigability is a concept which is different than the owning. So owning, it means is that if you model the class, that class might be an owner of the other element. But navigability means that you have a chance to move from one class to the instances of the other class and vice versa. So what it means, if I have let's see, what's time? Oh, I already, there is already after time, right? There is 12 to 11, so I should finish my lecture. So maybe I will come back to this during the laboratory assignments, or maybe during the next lecture. But please go through the rest of these slides, and you see that I am also explaining that with use of Java profile of UML, you can represent nested classes in such a way. With use of UML, you can depict the architecture of your system using component diagrams and deployment diagrams. These are examples which are very helpful when you describe your architecture. And I did not have a chance to talk about sequence diagrams and state machine diagrams. I will come back to them soon. And especially sequence diagrams quite often are assisting the description of design patterns. If you have a design pattern, you should deliver not only the, how to say, the example of the classes, but you should also describe the use case of, and you should also describe the behavior of that pattern. And usually this behavior is described using sequence diagrams. I will come back to this during the next lecture, or maybe during the laboratory assignments. However, please look at the slides and try to read a bit about the sequence diagrams and state machine diagrams and activity diagrams, because this is what should be known to you after that lecture. All right, so this is all from me for today. Any questions?
No, sir.
No, all right. Did you survive? There was a lot of information I offered to you today. You are still online, so it means that you are alive, I hope. I will come back to you during the laboratory assignments. Some of you already start the description of the requirements. Some of you are ahead of it. Anyway, you have some times to finish the first lab, so please use the time and deliver your descriptions. You can use in your descriptions SysML diagrams already, right? These were explained during that lecture. So thank you for coming. I hope you enjoyed the lecture, and let's meet during the labs and the next laboratory, next lecture. See you.
Thank you.
Thank you.
Thank you very much.
Bye.
Thank you, sir.
Bye.